Assalamu alaikum. Welcome to the seventh video. Still on the first material. Now, in the sixth video, we explain the first application of Newton's and conservation of momentum laws, which was recoil of the gun. Now we are going to solve problem that has to do with the recoil of a gun. Here, the problem is example 6.11. A rifle of mass 15 kilogram fires a bullet of mass 60 gram. Make sure you convert this to kilogram. You divide it by 1,000. Now you have a rifle. It has a mass of 15 kilogram, and then the bullet fired from the rifle 60 gram. And this bullet was fired with a velocity of 200 meters per second. The question is, calculate the recoil velocity of the rifle. What is the recoil velocity? In the previous video, we said when the bullet moves forward, the gun or rifle moves backward in the opposite direction, and it will have a negative velocity if we consider the velocity of the bullet positive. Now, the first thing we should remember is before firing, everything, the bullet and the gun, were at rest. So because they were at rest, the momentum will be zero for each one of them. This is why they say momentum before the firing of gun is zero. So you have initial momentum total zero. Then you go to the total momentum after collision, after firing. Momentum after the gun is fired. After the gun is fired, it will have momentum. The bullet will have momentum, mass of the bullet times velocity of the bullet. The rifle will also have momentum, mass of the rifle, and the recoil velocity of the rifle. So this is why here they say mass of the rifle, which is 15 kilogram, times its velocity. We don't know its velocity, so we use V, plus mass of the gun, but we have to divide this by 1000 to change it to kilogram because it is given in gram. This one is given in kilogram, no need for conversion. This is in gram, we have to divide by 1000, and this is why you see this divided by 1000. Then this now is the mass of the bullet. Then here is the velocity of the bullet. We multiply this. Okay, if you take your calculator and say 60 times 200, okay, the answer you obtain divided by 1000, it will give you 12. So it means now you can say 15 times V, it will be 15V plus, then this times this divided by this will give you 12. Okay, this is the total momentum of the system after firing. Now the initial was 0, so if according to the law of conservation of momentum, since momentum is conserved, we can say momentum after firing equals momentum before firing, which was 0. Now we take this and put it here equals 0. From here we take this is plus, we take it to the other side, it will be negative 12. Then you divide both sides by 15, it will be negative 12 divided by 15. This will be negative 0.5 meters per second. The negative sign, remember, tells you that the gun moves in opposite direction to the bullet. That is the interpretation of the negative sign. Then you conclude by saying the recoil velocity is 0.8 meters per second, meaning this is the velocity of the gun. Okay, you remove the negative sign. Okay, the next application is jet and rocket propulsion. Jet and rocket propulsion. The principle of conservation of linear momentum is also utilized in the propulsion of jet aircraft and rockets used for launching satellite. Gases are burned within the combustion chambers of the engine as jets of hot gases are expelled downwards through the tail nozzle at very high speed from the rocket or aircraft. An equal and opposite momentum is given to the rocket or aircraft, which then moves. Okay, I'm going to explain that. what they are trying to say. I need a diagram. Okay, here is the image. Wow. So look at this one. This is a rocket launch. Now, before the launching, the rocket was at rest, but then it will begin to eject hot gases. Think of the hot gases as the bullet, just like the bullet in a rifle. Okay, the hot gases will come out with great speed, with the action force. Okay, now the rocket would move upward with the reaction force. So you have action and reaction that are equal and opposite. Again, you can think of it as the recoil of a gun that we explained previously. When it was at rest, the fuel and the rocket were both at rest, so they have zero momentum. Total momentum before launch, okay, was now after the launch there is change in momentum. The fuel goes down with a positive momentum and the rocket is launched with a negative momentum, and the two momenta are equal and opposite. Okay, this is an application of conservation of linear momentum and of Newton's laws of motion. Okay, let's go back to the material. Okay, wow, interesting. Now look at this one here. Very interesting. Lawn spray. You have here it ejects liquid. This one also ejects liquid. So when liquid comes from the opening here with great force, this force is the action force. Now the handle here will move in the opposite direction with the reaction force. Here too, in this direction, you have the action force when the liquid come out, and then you have reaction here. So this will create rotation here. It will make the material to continue rotating, thereby spraying the liquid. Again, look at the aircraft here. Look at the aircraft here. As the aircraft is moving, it ejects hot gases here. Hot gases from the wing. Okay, when the hot gases are ejected with great force, you see hot gas expelled, they are expelled with great force, and then the aircraft will move forward with the reaction force. So this is also an application of Newton's law that says action and reaction are equal and opposite.